Today we're going to be talking about biconditionals and definitions. Now yesterday we talked about conditional statements and their converses and truth statements. And today we're going to be going a little bit deeper with that same idea. So biconditional statements by definition, all right, is a statement whose conditional statement and its converse are both true, and it contains the phrase if and only if. So, for example, we have a conditional. It says if two angles have the same measure, then the angles are congruent. Now the converse would be if the angles are congruent, then they have the same measure. Alright, so we know that both the conditional and the converse are true. Now, the biconditional is combining these two thoughts. So it would be two angles have are congruent if and only if they have the same measure. Alright, so basically what you're doing is you're taking the conditional and the converse and creating an if and only if statement. Okay? Alright, so we could say we have write two statements that form this biconditional about integers greater than 1. So a number is prime if and only if it has only two distinct factors, 1 and itself. So we know that to be true. So in order to take our biconditional, we can go the opposite way, and we can actually write the conditional statement and its converse. So we could say if a number is prime, then it has only two distinct factors. Which are 1 in itself. Alright, and the converse would be the exact opposite. It would be if a number has only two distinct factors, 1 in itself, then the number is prime. Alright, so the second part of our lesson today is talking about definitions. Alright, and there are some criteria about creating good definitions. So a good definition is a statement that can help you identify or classify an object. It has several important components. So we're going to go through those right now. The first one is it uses clearly understood terms that are commonly understood or already defined. You don't want to use big words that people are going to have to look up to figure out what your definition is. You want to use common language. Okay? All right. It's precise. It avoids words such as large, sort of, and some. Okay? You don't want to make it really vague. All right, and the last one is it's a reversible, meaning you can write it as a true biconditional. So, for example, we have if two lines, we can write a definition coming off of this. So we have if two lines intersect to form a right angle, then they are perpendicular. Okay. So we could write this as a biconditional. We could say when two lines intersect, or two lines intersect to form right angles, if and only if they are perpendicular. All right. So that is a very simple way of taking a definition and turning it into a biconditional. You can also go the opposite way. So for example, if I had the definition, or if I had the conditional, if an angle is a right angle, then its measure is 90 degrees. I can create the definition, a right angle is an angle whose measure is 90. Okay? It's concise, it's clear, it has simple language. We all know what a right, what 90 degrees is and things like that, so it is very common to understand. Okay? All right, that concludes our lesson on biconditional statements and definitions.